Evaluate the limit of a function root of x squared plus 1 minus x as x tends to 1. So we have this to solve. Solution. Now we have this given to us, limit of this function x squared plus 1 minus x as x tends to 1. As x tends to 1. So we have that to solve. Now for us to solve this, we multiply. Let's multiply both. This is over 1. This is over 1. So let's multiply both the numerator and denominator by the conjugate of this, so that will be simplified. Because while we're doing that, if we substitute directly here, we will not have any reasonable function that we are asked to get. If we substitute directly 1 into this will be 1 square, which is 1. 1 plus 1 is 2. And square root of 2, that will actually give you a little bit of headache for you to deal with. So we just go ahead and multiply the numerator and the denominator by the conjugate of this. Conjugate of this, what I mean, this what is separating this and this now is minus, so that the conjugate will be an opposite of that, which is plus. So we are going to have square root of s squared plus 1, then plus x. Then we do the same thing to the denominator rather. So square root of s squared plus 1 plus x. So we have that plus x. We have that plus x. Now when we multiply this, this will now become limit as x tends to 1. We have that. So when we multiply this is what we are going to have at the end of the day. Now if we multiply this, so since this and this are conjugate, this is from this minus and this is positive, so this and this are the same, so we can just pick the one that is negative. We square this and we square this. So if we square this, one, this square root of s squared plus 1, so if we square this, we are going to have s squared plus 1. And if we square this as well, we are going to have minus s squared. That is kind of a shortcut of doing this. So if you don't want to do it this way, you can expand. You can use this to multiply this, multiply this, multiply this. Then at the end of the day, you factor out and you get the same thing here. So the shortcut I just used was that since this and this are almost the same, a difference of their sign, pick the one that is negative, square the first term, then square the second term, then you will have this. Now all over this 1 times this is the same thing, so we have square root of s squared plus 1, so let me cover that, plus x. So we have this. So with this we can substitute now and we'll get something we can work with. Before we substitute, we can actually reduce this as well, because this is s squared minus s squared, so we'll be left with a limit of 1 as x tends to 1 all over the whole of this. So square root of s squared plus 1, s squared, this is s squared plus 1, then plus our x. So we have that. So let me just rewrite that. So limit of 1 all over as x tends to 1, square root of x squared plus 1 plus x. So I just have to rewrite that so that it will be clearer. Now let's substitute this our x to be equals to 1. So if we do that, we will be having 1 all over, substitute here, we have square root of 1 square plus 1 plus 1. So when we do that, we'll be having 1 all over square root of, this is 1 square is 1 plus this, we have square root of 2 plus 1. Now we can leave it as this, but let's multiply both the numerator and denominator by the conjugate. So if we do that, we will be having times square root of 2 plus, okay, that is not plus now because conjugate, that is minus 1. So all over square root of 2 minus 1. So we are multiplying by the conjugate. So when we do that, 1 times this whole setup here, we have square root of 2 minus 1 all over, like I said before, this time this is the same thing as take the one that is negative. I'm going to square this. Square root, if you square this square root of 2, you'll be having 2 because square root of 2 times square root of 2 will give us 2 according to the law of sort. So we have our minus 1 square is 1, so we have that. So this is now square root of 2 minus 1. This is 2 divided by 2 minus 1 is 1. So if I divide this, if I divide all this by 1, it's still going to give me the same thing. So this is my answer for that question.